Yes, hello everyone. I want to take this opportunity to welcome you to this platform again. This is our third lesson in science, and before we continue with the new concepts, I would feel that we go through the previous work. The first question was, the following substances are non-magnetic except, so we were supposed to tick or circle a letter that had the correct response. When you look at the queue or a list of words that were given, iron qualifies because it's the only substance which is not, which is magnetic, because the rest are non-magnetic. Then number 2 was a natural occurring magnet is, the right response was C, lodestone. Number 3, the poles of a magnet which attract each other are, so when we go to the properties or behaviors of magnets, we always say that poles which are unlike are the ones that attract each other. So in this question, letter C has the right word. Then number 4, a piece of soft iron is placed inside a coil in which an electric current is passing. When the current is switched off, so we are looking at a type of magnet which is normally made by using electricity or passing current through a coiled wire. In this type of magnet, once you switch off the current, it means the material which has been magnetized or that has gained magnetism will automatically lose its magnetism. So letter A qualifies to be the right answer. Then 5, a freely suspended magnet always comes to rest. This is also a behavior of magnets. They do behave in a way that when you suspend them, they will always rest facing north-south direction. So letter A has the right statement. So having done the corrections, today our dear learners, we want to look at the behavior or properties of magnets. The first property, or the way, one of the ways that magnets behave is like poles of a magnet repel. Earlier on, we learned about the poles of a magnet. We say that magnets have two ends called poles, and these poles are the North Pole and the South Pole. Now, in this way, we want to look at how do they behave when you bring the poles which are alike together. When you bring the poles which are alike near one another, they will always deny to come together, and that is what we call repulsion. So they will always repel, and that's why we are saying the first way magnets behave is they always behave in a way that they do not accept to come together once they are all of the same poles. The second property is that when you bring poles which are unlike together, they will always accept to come together, and that is when we say that unlike poles attract each other. There is something that we want us to learn. The first property that we have seen, that like poles repel, and the second property, that unlike poles attract, those two properties make up what we call the law of magnetism. So when they ask you that state one law of magnetism or state the law of magnetism, you say that unlike poles attract while like poles repel. The second way these magnets behave, or the third property, is what we say that when a magnet is fully suspended on a piece of thread, it will always rest facing in the north-south direction. This is because sometime earlier on we learned about the types of magnets, and we looked at the natural magnet and the earth qualifying to be one of them. When you look at the earth has metals underneath which behave like magnets. But one thing you have to know is that the earth is magnets. They have their south pole in the geographical north. So when you suspend a magnet on a thread, it will always rest facing in the north-south direction, because the north-seeking pole of the bar magnet that has been suspended will be always attracted by the south pole of the Earth's magnet, which is in the geographical north. Then the other behavior is that when you bring iron filings and try to always put them near where the magnets are, you will always find that the iron filings are more concentrated or more attracted at the ends of the magnet. So that behavior is what we say that the poles are the strongest part of the magnet, or magnetism is concentrated at the poles. That is why more of the iron filings will always be attracted at the end. Then the other behavior is what we learned some time back, that magnets have what we call magnetic lines. But magnetic lines of force always run from the north pole to the south pole. So that is another behavior that we see. We may not be able to see these magnetic lines of force, but since they act within a region where we can feel the force of magnetism, that is why we can always say that magnetic lines of force run from the north pole to the south pole. That is another behavior. Then the other behavior that we have to talk about is that magnetism passes through non-magnetic materials. We all now know what non-magnetic materials are. For example, wood and paper. Now, when you get a magnetic substance and you put it under a non-magnetic substance, and then you bring a magnet on top of it, those magnetic substances will always be attracted by the magnet. The force will be able to pass through the non-magnetic material, as you see on the screen, that diagram there. Then the other behavior or the other property is that when you break a magnet, when you break a bar magnet, the broken pieces will always gain their poles. So as you see on the screen, one bar magnet is broken, and what happens is that each piece becomes an independent magnet. So broken pieces of magnets regain their poles. Today we want to stop there, and I want you to try this activity. Thank you very much for attending.